Okay, welcome back to my scratch, and I guess I can complete more of those problems about force. And let's check number 21. It says that three balanced forces are applied to a box as in the figure below. If F1 equals to 2F2 and F3 equals to 9.0 newtons, what is the value of F1, I guess? Okay, so here it says it's a balanced forces, right? So balanced forces means what? Means the net force equals to zero, or in other words, the forces to the right equals the forces towards the left. So here I have F1 and F2 are pointing towards the right and F3 is pointing towards the left. So if these forces are balanced forces, so F1 plus F2 must equal to F3. And now I have F1 and what's F2? F2 equals to F1 over 2. F1 over 2 and F3 equals to 9 newtons. So I can now solve for F1 and F1 equals to 6 newtons. Problem number 22, it says that a worker is trying to slide a wooden box as in the figure below. He pushes the box by a force of 100 newtons due east, but the box does not slide. There is a friction between the box and the floor. What is the magnitude of the force or friction? So if the box does not slide, it means that this friction is a static friction. And as you guys know that the static friction is a reaction force and it must equal to the force of pushing. So if we push with 100, or if the worker pushes with 100 newtons and the box does not move, then the sliding friction must equal to 100 newtons. 23, it says that how does the gravitational force change as two objects move apart or move further apart from each other? Now, if you know the equation of the force of the gravitational force, it says that F equals to capital G m1 m2 divided by d squared. Now, this is called the universal gravitational constant, the first mass, second mass, distance between them. So what will happen to the gravitational force? When they move apart, it means when d increases, so the force must decrease. 24, it says that a person weighs 882 newtons at Earth's surface and 720 and 270 newtons at the surface of another planet. What is the gravitational strength at the surface of the planet? Now remember that the weight is just the mass multiplied by the gravity, and the mass should not change between Earth and any other planet. So what will change is the gravitational strength or the acceleration due to gravity. So if I divide the weight on the planet by the weight on the Earth, that gives me 0.30.6, and that must be the ratio between the gravity on the planet and also the gravity on Earth. So the gravity on the planet equal to 0.306 multiplied by the gravity on Earth, and the gravity on Earth is 9.8 meter per second squared. So the gravity on the planet must be 3 meter per second squared, or 3 Newton per kilogram. This is just another unit. And let's see 25. It says that if you use a horizontal force of 30 newtons to slide a sofa across a floor at a constant velocity, what is the sliding friction between the sofa and the floor? So if they tell you it's a constant velocity, it means that the net force equals to 0. And it means that the force of pushing equals to the sliding friction, so the sliding friction must equal to 30 newtons. 26, it says that assume your mass is m, the mass of Earth is capital M, and the radius of the Earth is capital R. Which of the following equations represent your weight at Earth's surface? So what is your weight? Your weight is just the gravitational force between you and the surface of the earth. And how we calculate this is the equation that we use, g m small m capital divided by r squared. So here they just test if you can memorize the force of the gravitational force between two objects. 27 says that you weighed yourself at the top of a high mountain and the scale reached 730 newtons. If your mass is 76.0 kilograms, what is the gravitational strength on that location? So here if I divide my weight by my mass, by my mass, it should give me the gravitational force because the gravitational strength or the acceleration due to gravity at that location. So here the g equals to your weight divided by your mass, which is 730 divided by 76.0, that would be 9.6 meter per second squared, or 9.0 Newton per kilograms. Okay, number 28. It says that a 10 kilogram block rests on the top of a 20 kilogram block which rests on a horizontal table. What is the force, magnitude, and direction exerted by the 20 kilogram block on the 10 kilogram block? Now remember that Newton's third law says for every action there is a reaction equals in magnitude and opposite in direction. So if you want to know what is the force that the 20 kilograms applies on 10 kilograms, you should know what is the force that the 10 kilograms applies on the 20 kilograms. So what is this force? It is 10 multiplied by 9.8, it's 98. So it's 98 downwards. So the 20 kilograms will apply at 98 newtons upwards. 29 says that if you use a horizontal force of 30 newtons to slide a sofa across a floor at a constant velocity, what is the sliding friction? Again, here is a keyword. Sliding constant velocity. It means that the net force applied is 0. So the force of friction must equal to the pushing force, which is 30 newtons. So the answer should be A. Now, number 30 is a repeated question. It says that assume your mass m and the mass of Earth is capital M, the radius of Earth is r, which the following equation represents your weight on the Earth's surface. So again, your weight here would be the gravitational force between your mass and the mass of the Earth, which is F equals to capital G m1 m2 over distance squared, and here we can just pick answer number A. Now 31 is a kind of a tricky question. It asks that three masses are located as shown in the diagram below. The distance between m1 and m2 is x1 and the distance between m2 and m3 is x2. If m3 equals to 4m1 and x2 equals to 2x1, what is the net force on m2? So if you want to find what's the net force on M2, you should think what is making this force. So you'll find an attraction between M1 and M2, another attraction between M3 and M2. Now remember that we only concern about M2, so if you want to know which way M2 will move because of the attraction between M1 and M2, then F1 should represent the direction of the force. And if you want to know which way M2 will move because of M3, then the direction of F2 should represent this kind of motion. Now, if this to find the net force, it must be F1 minus F2 or F2 minus F1, doesn't really matter because we want to find what's a net force. So now first thing I want to find what is F1. F1 equals to G m1 m2 divided by the distance squared, x1 squared. And what is F2? Equal to G m2 m3 divided by x2 squared. So what is the net force? it is F1 minus the F2. So it's a G M1 M2 divided by X1 squared minus G M2 M3 divided by X2 squared. Now, if I look back at the problem, X2 equals to 2X1 or 2X1 all squared. That would be 4X1 squared. Now, also M3, let's check, where's M3? M3, it was somewhere, yeah, it is here. M3 equals to 4M1. So I can now replace M3 with 4M1. Now you cancel 4 with 4. So you end up with GM1 M2 over X1 squared minus GM1 M2 over X1 squared. Can you see this? These are exactly the same. So they will just cancel out and the net force should equal to 0. Now let's check 32. It says that a 5.0 kilogram block rests on the top of a 10 kilogram block which rests on a horizontal table. What is the force, magnitude, and direction exerted by the 10 kilogram block on the 5 kilogram block? So again, this is the Newton's third law. For every action, there is a reaction equals in magnitude, opposite in direction. So if I want to know how much force the 10 kilogram will act on the 5 kilograms, I need to know what is the force that the 5 acts on the 10. And the 5 acts on the 10 by its weight, which is 5 multiplied by 9.8, which is 49. But remember, I don't want the force that 5 acts on 10. I want the force which 10 acts on 5. So it must be towards the north, which is 49 newtons north. Next one, 33, it says that the gravitational potential energy of an apple Earth system changes when which factor change or when which factor changes. And of course, we know that the gravitational potential energy equals to m multiplied by g multiplied by h. So the gravitational potential energy would change if any one of these three factors change: the mass, the acceleration to the gravity, or the height. So here I have the mass, which is okay. The speed doesn't change, doesn't do anything, has nothing to do with the gravitational potential energy, neither the temperature or the size of the apple. The only thing that can change the gravitational potential energy is the mass of the apple. Number 34, it says which of the following sets of forces are unbalanced forces when acts on an object. Now here what I want you to do is to get a pen and a paper to do this calculation yourself. Now remember, these are unbalanced forces. Unbalanced means they will not add up to 0. So what you need to do is to check east and west, north and south, and see if they can cancel each other. If they cancel each other, then it will be balanced forces. But if they cannot cancel each other, then it would be an unbalanced force. So here you can see the only option that they do not cancel is the option A, because here you have 5 newtons, here you have 5.6 newtons. So the east and the west will not cancel each other. Let's check number 35. It says that a boy pushes on a desk and the desk slides horizontally across the floor with a constant speed. If the sliding friction between the desk and the floor is 10 newtons, how much force must the boy apply to maintain the desk at constant speed? Again, this keyword, constant speed, means that the pushing force should equal to the friction. So if the box moves at a constant speed, so the pushing force must equal the friction, which is again 10 newtons. Now let's see number 36. It says that if the Earth were 3 times as far from the Sun as it now, the gravitational force exerted on it by the Sun would be what? Now remember that the gravitational force is given by G m1 m2 over r squared. Now here I have the two objects. One of them is the Earth, the other one is the Sun, and r is the distance between them. So if they say that the distance is 3 times far, so it means that it means that um, I have to make r equals to 3r, right? So it should become 9r squared. So this is wrong. It should not be 1 over 9r squared. It should be 9r squared, because it's a 3r squared, so it would be 9r squared, and then the answer would be 1 over 9, if because it means that the force will equal to 1 over 9, the current force, which is g m earth m sun over r squared. So just we need to fix this. This is wrong, because it's a 3r all squared, which is 9r squared, right? So this is supposed to be 9r squared, and that gives you 1 over 9. Next question says that an astronaut has a mass of 100 kilograms and weight of 327 Newton on another planet. We want to find what is the gravitational strength on that planet. If they say what is the gravitational strength, it means that they want you to find the g, the small g, which is the acceleration due to gravity. And if the weight is 327 newtons and the mass is 100 kilograms, then you divide the force by the mass. That gives you the g, which is 0.33, or 1 over 3, the gravity on Earth. Now let's check 38, and it says that the gravitational field strength at the surface of Earth, which is at a radius r from the center of the Earth, is approximately 9.8 Newton per kilogram. What would be the gravitational field strength at a height r above the Earth's surface? So the radius of the Earth is r, and you want to find what is the gravitational strength at a height r from the surface. So it means that the distance is now double. So you just need to use the equation for the gravitational strength, which is g equal to capital G m over r squared. But now you need to replace r with 2r, so it becomes 4r squared, and that means that it would be 1 over 4 of the current gravitational strength. Now multiply 1 over 4 times 9.8, or divide 9.8 by 4, and this should give you the answer A, 2.45 Newton per kilograms. And next question, which is the following sets of forces are balanced forces when acts on an object? I guess we have just answered something like this. Here you can see, but here they ask you if they are balanced. So balanced means that the net force equals to 0, and I can just see that it is the first answer, because the other answers do not give us a balanced force. So balanced means that you need to add east and west together and north and south together, and they should give you 0. Like, for example, if you pick up the answer B, you will see that the east is 20 and the west is 10. So the net force will be 10 towards east, and the north is 10 and the south is 20, so it should be 10 toward the south. These are unbalanced forces, right? Balanced means that the net force must equal to 0. So I guess that's all for these kind of problems. Hope you guys now comprehend these problems. I guess you have to focus on mostly on the problems that talks about the gravitational force. How do they change by the mass and by the distance? You also should focus on the problems that speak about friction and so on. Otherwise, everything should be straightforward and easy. Okay, thank you so much. I will see you inshallah on other videos.